What if the universe isn't a grand cosmic design, but a program with flaws? From particles that behave differently when watched to the invisible forces shaping our galaxies, some of the strangest discoveries in physics are starting to look less like science and more like signs of a simulation. In this video, we explore the eerie anomalies, quantum entanglement, the double-slit experiment, dark matter, and black holes that some believe are the glitches revealing our reality's hidden code. Quantum entanglement is one of the strangest and most debated phenomena in modern physics. When two particles become entangled, their states remain connected no matter how far apart they are, even across galaxies. Change the state of one, and the other seems to respond instantly. Einstein famously called this spooky action at a distance, because it appears to defy the universal speed limit, the speed of light. But what if this isn't just weird physics, it's a sign of something deeper? In the simulation theory framework, entangled particles could be compared to two variables linked in a single line of code. They don't communicate through space. Instead, their state is managed centrally, as if the system updates both at once. This would explain the instant correlation without requiring faster-than-light travel. Could quantum entanglement be a shortcut built into the system to optimize performance? If our universe is a simulation, this might be one of its most telling signs, a glimpse behind the curtain at the strange but efficient logic of whatever is running the show. The double-slit experiment is one of the most iconic and unsettling demonstrations in quantum physics. When particles like electrons are fired at a barrier with two slits and no one is observing them directly, they behave like waves, interfering with themselves and creating a pattern on the screen behind the slits. But when a measuring device is placed to observe which slit the particle goes through, everything changes. The interference pattern disappears, and the particles behave like solid objects, as if they knew they were being watched. This strange shift has puzzled scientists for decades, and it raises a profound question. Does reality exist independently of observation, or is it somehow rendered when measured? In the context of simulation theory, the implications are staggering. Just like in a video game, where the environment only loads when a player gets close enough to see it, our reality might only collapse into a specific state when observed. The particle doesn't make a decision until it's forced to, possibly to save on processing power, or because the system doesn't simulate what isn't being actively interacted with. The double-slit experiment could be more than a quantum oddity. It might be a peek into the mechanics of a universe that isn't fundamentally real, but computed. If observation creates reality, then what is reality when no one is looking? In the vastness of the universe, there's a silent, invisible force dominating everything we see, yet we can't detect it directly. Scientists estimate that around 85% of the universe's mass is made of dark matter, while dark energy is believed to be responsible for the accelerated expansion of the cosmos. Together, these two make up over 95% of the universe, but we have no concrete idea what they actually are. This has led some to speculate, what if these mysterious forces aren't real substances at all, but patches or placeholders in a simulated reality? In programming, when something doesn't work quite right, developers often insert variables or temporary fixes to keep the system running. In that light, dark matter and dark energy could be signs of a cosmic patch, a way for the simulation to balance gravitational equations and expansion rates without fully modeling the complex inner workings. After all, why would a simulation waste processing power on fully rendering every detail of deep space when most of it is never observed? Instead, it might use simplified variables. Dark matter to glue galaxies together, dark energy to drive cosmic acceleration, and only calculate the real physics when absolutely necessary. Rather than being clues to new forms of matter, dark matter and dark energy may be telling us something much weirder, that our universe is incomplete by design, a system with shortcuts and duct tape holding it all together. Black holes are among the most mysterious and extreme phenomena in the universe. These dense regions of spacetime pull in everything, matter, light, even information, beyond the event horizon, from which nothing can return. But what really happens inside a black hole? According to mainstream physics, the laws of nature as we know them break down at the singularity, where density becomes infinite and time itself may cease to function. To simulation theorists, this isn't just an extreme astrophysical anomaly, it could be a sign of a deeper computational boundary. Imagine a black hole not as a physical object, but as a system crash or reset zone, a place where the simulation's code can no longer resolve the physics it's supposed to render. Some theories even suggest that black holes could be portals to other universes or entirely new simulations, much like a reboot or a transfer between server instances in a vast digital cosmos. Then there's the black hole information paradox, the unsettling idea that information that falls into a black hole might be lost forever, which contradicts quantum mechanics. This has led to hypotheses like firewalls, where intense energy at the event horizon burns up incoming data, or the idea that the universe somehow preserves the information on the edge of the black hole, like a hard drive writing to a backup system. Both ideas hint at the possibility that black holes are more than cosmic vacuum cleaners, they're nodes in a system, where reality is rewritten, corrupted, or offloaded. In this view, black holes aren't just astrophysical oddities, they're glitches, failsafes, or deep system processes in a simulated universe. If the cosmos were a program, black holes might be its reset buttons, error handlers, or portals to new levels of reality. When we zoom out and look at the universe through the lens of modern physics, we find more than just mystery, we find patterns that eerily resemble the quirks and limitations of a coded system. Quantum entanglement feels like instant data syncing. The double-slit experiment behaves like a world that renders only when observed. Dark matter and dark energy resemble placeholder variables in incomplete code. And black holes might just be cosmic reset zones, where the rules of reality collapse or restart. These aren't just metaphors. They're legitimate questions science still struggles to answer. And while simulation theory remains speculative, the anomalies we've explored suggest one chilling possibility. The universe we trust may not be a natural, physical realm, but a designed experience, optimized for efficiency, limited by processing, and governed by rules that break down under close inspection. So, are we living in a simulation? No one knows for sure, but the glitches are there and they're waiting to be noticed. If you liked this video, please give us a like, leave a comment behind, and don't forget to subscribe, since we have a new video every day. Thanks for watching.